Hey there, crazies. Do you ever wonder if we're living in a giant simulation? Because I do. Here at the Science Asylum, deep philosophical questions are nothing new. Having clones and teleporters around brings up all sorts of questions, but asking if the universe is a simulation calls into question our entire existence. The movie 13th Floor jumped headfirst into this madness. It's one of the deepest questions we've ever covered, so let's start a little smaller. What kind of things do we simulate, and why? Randy suggested the three-body problem, which takes us back to the days of Isaac Newton. Since the invention of Newton's laws, we've been able to make amazingly accurate predictions about the motions of the planets and their moons. But there's a problem here. Newton's first and second laws of motion only apply to one object at a time. And Newton's third law of motion and his law of gravity only apply to two at a time. That's great if all you're trying to do is model the Earth's orbit around the sun, or Pluto and its moon Charon. You just do some math on it and booyah! Equations of motion. They map out any planetary path. Circular, elliptical, parabolic, hyperbolic, including the Earth's. But what if you want to see what happens to the moon? That's the three-body problem, and it's drastically more complicated. So complicated, in fact, that in 1887, Poincaré and Bruns showed it wasn't even possible to solve. Equations of motion are super useful. You want to know what the Earth is doing 70 days from now? You just plug in 70 days and bam, you've got your answer. You want to know what the Earth is doing 70,000 years from now? You just plug in 70,000 years and bam, you've got your answer. But when you've got three objects, all bets are off and things get super weird. Here's what the Earth and Moon's orbit looks like around the sun. Well, not really. It's exaggerated. This is what it actually looks like. It's almost like the moon orbits the sun. Huh, weird. Anyway, if you've got three objects that are all comparable in mass, then it's hard to find stability, at least until one of them is thrown away. This problem isn't limited to just gravity either. It's a big problem for atoms too. Hydrogen is only two objects, so no problem. But helium is three. Big problem. Honestly, having only three objects isn't all that realistic either. The solar system is made up of a star, 8 planets, and a bunch of moons, asteroids, and comets. Most atoms have a ton of electrons in them, all repelling each other. It's part of why it took us so long to figure out the periodic table. It's madness! So how did you make all those animations if it's unsolvable? I simulated it with computer code. See, if you're good enough at coding, you don't need an equation of motion. You just step the laws forward, one little moment after the other. If you make your time steps small enough, the animation looks smooth. The downside is, if you want to know where something is and what it's doing at a certain time, you have to wait for the simulation to get there. But doing things in real time can get real impractical real fast. So you're going to want to speed it up a bit. And if you max out your computer, there are only two options. One, you can make the time step bigger, but you start accumulating errors over time. Or two, you can get more processing power, either by getting a better computer or by linking computers together. Why are we talking about this? Because this is actually how the universe works. Even though we sometimes use math to get equations of motion, the original laws are only defined locally in space and time, meaning the universe doesn't do any math either. It lives in the moment. So if our universe is just a simulation, it must have a time step. What about Planck time? That would make Planck time a single moment in time, and Planck length the size of a 3D pixel, or voxel. OMG, we're living in a super high-res version of Minecraft. Planck units only have physical significance in quantum gravity, which isn't a thing yet. Dang it! That would demand a lot of processing power too, about 10 to the 120th power gigahertz, give or take, which might explain why particles only have definite properties when they have to. So I don't know, do you think the universe is a simulation? Let's have a conversation in the comments. Thanks for liking and sharing this video, and until next time, remember, it's okay to be a little crazy.